Hi, welcome to Mrs. Thompson's classroom today. Today we're starting our unit on systems of equations, and so we're going to be talking about both substitution and elimination method for solving these systems. Then we'll also classify the systems in different types, and we'll see a word problem at the end of the video to apply these things. So let's look at the first one. A system of equations is any set of multiple equations that are connected in some way. So the first question we might add is a particular point a solution? Well, what does this mean? A solution simply makes both equations true. Okay, so then I just plug it in. So I'll take this is our x and this is our y. So I take the first equation and that'll become 2 times 1 plus negative 1 equals 1. And the question mark is that true? So I have 2 minus 1 equals 1, and that's true. Okay, then I plug it into the second equation. So I'll have negative x plus 2 times my y. And the question is, does that equal 7? So I have negative 1 minus 2, which equals negative 3, which is not equal to 7. So the answer would be no. It made the first equation true, but not the second one. Okay, so let's try this one. We'll put this into the first equation. So 2x plus y equals 1 becomes 2 times 1 plus a negative 3, which is equal to 2 minus 3, which equals negative 1. Okay, and then if we plug it into the second equation, we get negative x plus 2 times negative 3 equals, that's negative 1 minus 6, which is negative 7. So it's actually not true for either. So this is also not a solution. If it made both of them true, then we would say yes. So then the question is, well, how do I find the actual solution? Well, graphically, the solution is where the two equations overlap. In other words, where they intersect. So we're going to graph the two equations. Okay, so 2x plus y equals 1 means y equals negative 2x plus 1. So we're going to have a y-intercept of 1 and a slope of negative 2. So down 2 over 1. And I can go down 2 over 1. And I can do that as many times as I need until I get the ability to connect the dots. And here's equation 1. Okay, then equation 2, I have negative x plus 2y equals 7. So 2y is 7 plus x. So that makes y equal to 7 plus x over 2, or 7 halves plus 1 half x. So my y-intercept is at 7 halves, which is 3 and a half. So 1, 2, 3 and a half. My slope is 1 half, so I'll go up 1 over 2. Up 1 over 2. I could even go down 1 and to the left 2, and then I can connect those dots. Okay, so it looks like the solution is right here at negative 1, 3. And then again, you could check it. So in the first equation, that would be negative 2 plus 3, which does equal 1. And in the second equation, I would get 1 plus 6 equals 7. So it does work in both. Now the problem with graphing them is if they intersect at a fraction, it'll be real hard to find it exactly. And if we don't graph the functions very precisely and use a straight edge and all of that, we might intersect incorrectly. So we want other methods. So there are two other methods called substitution and elimination. So we're going to solve this system both ways so you can see how it works. So let's use substitution first. Substitution simply means we're going to substitute or replace one variable for another according to how they're related. So this first equation will tell me that x is 1 plus 3y. So then in the second equation, I have 2x plus y equals 9. So I can replace x with what x is actually equal to. And now I only have one variable, so I can solve. So I'm going to distribute the 2. Okay, so then I have 2 plus 7y equals 9. Subtracting 2 will get me 7y equals 7, so y is 1. Now once I know y, I can come back up here and know that x is 1 plus 3y using this value right here. So that's 4. So my solution is 4, 1. Okay, now let's do this one with the elimination method. Okay, so in the elimination method, my goal is to get rid of one of the variables. We're going to eliminate it. It doesn't matter which one, except sometimes the equations will be more set up for one than the other. Now, in order for them to go away, what we're actually going to do is combine the two equations. So another name for this method is linear combination. But in order for them to go away, their coefficients are going to have to match. So what I'm going to do is I'm going to take equation 2 and I'm going to multiply by 3. And what that gives me is 6x plus 3y equals 27. Now notice you have to multiply the entire equation by 3. Then we're going to add these equations together. So I get 7x plus 0y equals 28. Notice I have a negative 3 and a positive 3. That was the reason we multiplied by a 3 to begin with. I needed the y's to have the same coefficient with opposite signs. Okay, so I have 7x equals 28. So that gives me x equals 4. Once I know x, then I can come back into either equation. I'll just use equation 1. So x is 4. So now negative 3y would equal negative 3, and y will equal 1, and I get the same solution I had before. Okay, now if your system is already set up with an x equals or a y equals, then substitution method's going to work faster. Otherwise, generally elimination will be a little quicker. Sometimes you even have to multiply both equations by something in order to get a least common multiple and to find a common value, a common coefficient. And then, of course, the other way is to graph the equations. So if we, oh my goodness, that's not a very straight line. But the first equation becomes negative 3y equals 1 minus x. So y is negative 1/3 plus 1/3 x. So negative 1/3 is about here. Then I'm going to go up 1 and over 3. and connect those dots. Okay, so that makes this point right here at 3 2/3. Okay, the other equation then becomes 2x plus y equals 9 becomes y equals negative 2x plus 9. So I have to go up to 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I go down 2 over 1. And I can connect those dots. And the question is, where does this intersect? Well, we know from our other work this should be at 4, 1. But just by graphing it, I might not have been certain that it was precise. So sometimes the graphing really is not the way we want to go. Okay. Okay, so now we're going to have a couple more practice problems. So you might want to just try them on your own. And I don't know why some of my work is showing up there. So we'll just skip on past that. Know that your answers are 2 and 4 and 1/2 and 1. So you might want to pause the video for a minute and see if you can work through that and then check and see how I did it. Okay, I did the first one by substitution and the second one by elimination. Okay, now how many solutions can a linear system have? Well, if we have 2 lines, they could be parallel and have no solutions. Okay, or they could intersect like this and have 1 solution. The other option is that we have a line and then the second equation just happens to be exactly the same line, which means we actually have an infinite number of solutions. Now, each of these pictures has a different name or a different type that we would call it. So the first type would be, we would call this inconsistent because there's no solution. Okay, these are consistent because they have a solution, but they're also independent because they are 2 different lines. Okay, and then this one is consistent because it has a whole bunch of answers, but really what we want to call it is dependent because they're actually the exact same line. They depend on each other. So let's solve this one. So I notice that I have a 1 and a 2 for the y, so I'm going to use elimination and multiply this first equation by -2. So I'll get negative 4x minus 2y equals negative 20. I'm going to repeat, just write down the second equation and not change it. And then I'm going to add the 2 equations together. And notice I get 0x plus 0y equals negative 2. So what I really have is 0 equals negative 2. Now this is a false statement, so there is no solution. This system has no solution, so therefore it is inconsistent. Okay? All right, let's try another one. So again, in this problem, I have y equals set up for me. So I'm going to plug that y in and use substitution on this equation. So I distribute the 2 and I get 8x plus 2 minus 8x equals 2. Notice 8x and negative 8x go away and I get 2 equals 2. Well, this one is always true. So this actually has an infinite solution and these are dependent. Okay, so my solution, we would actually just put that it is the set of points x, y such that y equals 4x plus 1. So technically there are an infinite number of solutions. Notice we do not want to say just all reals, because saying all reals is referring to a singular variable, just like saying x can be all reals, which in this case it can be. However, y can only become what x tells it to. So in the long run, y is going to also be all reals, but they have to relate to each other correctly. So we can say there's an infinite number of points, and then the set would look like this. Okay? So how do we know if they are consistent, inconsistent, dependent, or independent? So remember, inconsistent is the parallel, no solution. Consistent has a solution. Okay? Dependent has an infinite number of solutions. And independent are going to have are going to be two separate lines, and we can be either independent, consistent, which would mean two intersecting lines, or we can be inconsistent, which means we get two parallel lines. Okay, so let's take a look. Inconsistent, being parallel, would mean that the slopes are equal. Okay, dependent means they're actually the same equation. So that means they're going to have the same slope and the same y-intercept. Okay? And in order to be independent, consistent over here, they're going to have different slopes. Okay? All right, so let's take a look. All we have to do is figure out first and foremost what their slopes are. So in this particular problem, my slope is going to be -4 over 2, because we take these two values and change their sign, and so that's going to be -2. In this case, in the second equation, our slope is going to be -1 over the -2, so that's 1/2. So different slopes means we have consistent, independent. Okay, in this second set system, the bottom equation tells us that slope is -2. In the top one, it's the same as this top equation in the first one, so we'll get m equals -2. So they are the same. So then I need to look at the y-intercepts. So this one has a y-intercept of 3. But what is the first equation's y-intercept? For that, I need to actually do a little investigation. To get a y-intercept, that means x is going to be 0. So that means 2y equals 5, and y is 5/2. So the y-intercepts are not equal. The slopes are equal. This means these are parallel lines, which means they are inconsistent. Okay? And then finally, in this last set, I still have a slope of -2 for the top one. I have a slope of -2 in the bottom one. But now, look at my y-intercept here. So notice here, the y-intercepts are equal. Therefore, our slopes are equal, our y-intercepts are equal. So these are actually the same equation. So we would call these dependent. Okay. So I don't have to graph them to figure it out. I have to look at their slope and their y-intercept, and then I'll know everything I need to know. Okay. All right, here's our last question. So we're going to take part A, just says to write the cost function. So we have a fixed cost of $7,000. And then we're going to cost $5 for each unit, for X units. Okay. Our revenue is how much they're selling it for. So they're selling it for $12 each. Okay. Then for part C, the break-even point is actually where their profit equals 0. Now, profit is revenue minus cost. So this also means that revenue is going to equal cost. So I can simply take 12x and set it equal to 7,000 plus 5x. That'll get me 7x equals 7,000. So that means x is 1,000 units. So to break even, in other words, have no loss but no gain, I have to sell 1,000 units. Okay, and then finally, for part D, the profit of 2,000 is going to equal the revenue of 2,000 minus the cost of 2,000. Okay, the cost is all the outgoing money that the business has. The revenue is all the income that the company has. And the profit is what is left over. So the revenue at 2,000 is going to be 12 times 2,000. The cost is going to be 7,000 plus 5 times 2,000. So I'm going to get 24,000 minus 7,000 minus 10,000, because I can distribute the negative through there. So 24,000 minus 17,000, so I'm going to have a profit of $7,000. Okay, so this is just a place where these systems can come in handy. Our system was these two equations here. Okay. All right, so hopefully that helps you get a little idea of how to solve systems of equations, and please feel free to comment down below and subscribe, and we will see you next time. Bye.